Welcome to Industrial Problem Solving. My name is Dave Roysam. I am super excited to continue this new mini-series on troubleshooting using a form of pattern recognition. In this clip, we will discuss one of the most common patterns, that is, a defect or other trouble that favors one edge of a machine. I know your time is precious, so let's get started. Taper is defined here as any problem that favors one edge or another. That edge may be the front operator or tending side or the back driver gear side, depending on the language you use in your plant. A most important word in this definition is favors. The problem may come and go, as is almost certainly the case. It also may be occasionally seen on the other side, in which case we may have a superposition of a smile and a taper. In that case, the problem seen on both sides, but more noticeably on one, we'd likely have two distinct factors for the same defect outcome. One of the dozens of pitfalls that I teach about in my troubleshooting classes is the most common observation that we don't always have the problem. This most common observation is often one of the least useful because it usually adds no information. Of course you don't always have the problem. If you always had the problem, you would be out of business. And if you never had the problem, we would not be working on it. Ergo, of course the problem is come and go. Please note that a come and go problem can result from ever-present physics. For example, the common cold sore on the lips is caused by the herpes simplex virus. Somewhere between half and 3/4 of all people have that virus. They were usually exposed to it before they were 5 years old, perhaps by a kiss as a baby from your aunt or your grandmother. Some people who carry the virus never show symptoms, and for those who do, the malady comes and goes, often associated with some stressor. So, sunlight or stress does not cause cold sores, but it can trigger them. To add insult to injury, statistics will not be of much help in understanding the problem. It would suggest, for example, that sunlight or stress causes cold sores, and in the process, we may miss the virus entirely. In problem solving, we should initially try and focus on finding the root cause mechanics rather than the trigger. The reasons for an initial root cause mechanics focus are compelling. First, the root cause is ever present, and thus is usually easier to find. In contrast, triggers may be difficult or even impossible to find, especially in complicated and noisy industrial situations. Second, the root cause is usually the strongest of all the factors. Triggers are usually weaker factors, though we will sometimes find them more economically attractive. Finally, we often have science as a guide for root cause mechanics. One important word here is mechanics, because for many problems there is no single root cause per se, as we will see in just a couple of slides for this roller misalignment wrinkle. In short, start with science. Tapers may not always be easy to recognize at a glance, especially if it is combined with some other factor. For example, this histogram of defect frequency versus CD position is a tipped smile. This would probably be due to a combination of two entirely different factors or mechanics, one causing taper and another causing a smile. These factors appear to have similar strength in this example. Thus, two different factors of similar strength for the same defect. The taper factor may, for example, be simple roller misalignment in an oven. The smile factor for the same defect, for example, may be cool edges in that same oven, or perhaps it is something else or somewhere else entirely. We will have much more to say about smiles and frowns in the next clip. Another common combination that may disguise tapers is taper plus thresholding. Here we might have physics that extend the entire width, but the mechanics are only sufficient to generate a complaint at the extreme edge. With thresholding, the extent of the physics are hidden. Unfortunately, it is not possible to discriminate between a pure single-edge physics and a tapered physics without knowing more about the specific mechanics involved. Web handling science comes to the rescue again. One of a zillion examples of edge-favoring behavior is in-plane roller misalignment that can cause shear wrinkles. The problem only shows on one edge, but the physics span the entire width. However, the mechanics of this problem also requires tension and traction in addition to misalignment. This science is so well developed that operators can calculate required alignment precisions using only their thumbs, a smartphone, and a wrinkle predictor program by Abbott app. You can learn more about this wrinkle and the 20 others in my award-winning and trademarked Web 101 school that has been taken by 5,000 students just like you. While roller and nip misalignment can be one cause of edge-favoring behavior, it is by no means the only cause. Thus, while precision roller alignment may be prophylactic, it may not solve the problem if roller misalignment was not the root cause. Thus, we see one of the limits of pattern recognition. That is the same one shared by statistics. That is, correlation does not imply causation. It is best first to go to school, then do a literature search, and finally, possibly even consult with experts to help uncover the underlying physics. Without physics to guide you, you may end up going on a 6 Sigma statistical fishing expedition that yields correlations, but no understanding. One essential troubleshooting goal is to determine who owns the shape. Is it man, material, or machine? Or more specifically, is it you, your supplier, or your customer that is responsible for the trouble being on the backside, for example? In some cases, and with some shapes, this is easy to determine. For example, if we have a roll-to-roll process and we can flip the unwinding roll, then we might learn who owns the variability. If the defect which was on the backside then moved to the front side, we can then conclude that the web owns the variability. If the defect did not move, then the processing machine owns the variability and is responsible for the backside misbehavior. This test is usually best done by flipping the unwinding roll in the middle of a run instead of between rolls. Unfortunately, this powerful tool does not work with systems where it is physically impossible to flip the web. Unfortunately, this powerful tool also does not work with smiles and frowns, in which case we need to use other tools. These and scores of other tools are covered in my 2-day industrial problem-solving course, as well as some of the modules in this Web 401 series. Thank you so very much for joining me in this problem-solving and problem-preventing series based on web profile. Stay tuned for the next clip where we will talk about other common but even more challenging shapes, frowns and smiles. If you found anything interesting or useful here, please like and share. Also, please consider supporting the work of this channel using the Patreon link below. Patreons are given special thank you gifts ranging from email help to a signed copy of my latest book, the must-have 500-page Web Handling Handbook. See you next time.